Now, before we start learning Objective 2.2c, I want to start talking about a process the book refers to quite a bit going forward. It's called the four-step process, and it stands for state, plan, do, and conclude. When you have the 6 free response questions for your AP exam, I would say maybe one of those you're going to have to be very formal in your process. When we hit the latter half of the chapter, we do this all of the time in our learning. So we're going to start getting used to it now. So the first thing they're going to ask you to do is basically if they give you a free response question and they want to know your analysis of it, you want to state what's happening, do your plan, do the calculations, and make a conclusion. So for state, it's basically express the problems in terms of the observed value x. So you basically just talk about what we're going to do in the problem, and we don't have to say a lot here. Now, part 2 is the plan. In the plan, we're going to draw a picture of the distribution and do our shading. And we've done that for all of the previous examples, so we're used to it. Now, the do part is going to be to perform the calculations or show your calculator speak. So you could do either method here using table A or calculator speak. Be careful again, if we do the calculator speak, you must list the distribution and the parameters, which basically means, say it's a normal distribution, and you state your mean and standard deviation. And also in this do part, you do want to actually get the answer. Now after we get the answer, we're going to make our conclusion, and you basically just write it in the context of the problem. And for chapter 2, this just basically means once you find your probability, you might say it's a 68% chance that you get, the boys with the heights in between 2 different ranges. So just talk about the context of it. Do keep in mind the state, plan, do, and conclude process is very similar when we hit the other chapters, but some things might adjust. For example, the plan, we're not going to be drawing the pictures of the distributions. It might be a different question. So we'll talk about that as we get to it in more detail. Now let's just look at this one example. We're going to be talking about here, it's a normal model that describes the fuel efficiency of cars registered in our state. The mean here is 24 miles per gallon, standard deviation is 6. So by the way, the shorthand for that, it's a normal with 24 and a 6 if you want to write it like that. Now in part A, they want us to find the percent of all cars that get less than 15 miles per gallon. So the first thing I'm going to do is actually sketch this scenario real quickly. So the normal distribution, I'll just do a quick little nice symmetric curve, and 24 is in the middle. Now the problems we looked at in the previous learning objective, we had the means of 0 and standard deviation of 1. We actually used the z-scores. Well, you can use normal CDF with numbers that aren't z-scores, by the way. So this is our curve right here, again, mean and standard deviation. So I'm going to go ahead right here and say that's the mean, and I'm going to label that as the standard deviation. In our picture, we want to look at cars that get less than 15 miles per gallon. So I'm just going to estimate 15 is right about there, and less than is going to be right in here. So what I can do is, again, piggyback off of normal CDF. Now if I do that, I have to list my lower bound and upper bound. The lower bound on here goes to negative infinity, so I'm just going to say negative 999. My upper bound is 15. Now, my mean and standard deviation, I can actually use the given mean of 24 and the standard deviation of 6. And all you need to do is you put that in the calculator. When you put that in the calculator, it's going to kick back that the area is going to be 0.0668. So about 6.68%. And check for reasonability. This isn't the best graph, but that seems reasonable that it's almost about 7% per my image. Now I will tell you there is a second way to have done this one with normal CDF. If you wanted to, what you could do is you could actually convert 15 to its appropriate z-score. If you found the z-score for 15, we know it's going to be negative, you could put the z-score here. If you convert the actual numerical values to z-scores, then you would have to use 0 and 1 accordingly. Now if you did that, what you would say is the z-score is going to be 15 minus 24 over 6, which is going to get you a negative 1.5. Now if you again use the normal CDF, you would just adjust it like this. You would still keep the normal CDF, and I'm just going to abbreviate there, do negative 999, I'd put negative 1.5, and you do 0 and 1. If you go ahead and try that, you're going to see that you get exactly the same answer. So just know there's two approaches to doing these probability questions. Personally, for this scenario, I'm going to take the easiest, and I'm just going to keep it with its raw data and use 24 and 6. I'm going to be careful on my calculator speak that if I do normal CDF, I'm going to highlight that that's the mean and standard deviation, and we're good. Now, part B here I'm going to do in the state plan do and conclude format, so you can see how one of those works if you're asked to be more detailed. So I got it set up really quickly with the 4 components. Now what I'm going to state on here is say that they want us to find the percent of all cars between 20 and 30 miles per gallon. So that's all you would really do for state. And I would tell you, if you had to do a true free response on the AP Board's exam for this, the state for the probability part, you don't really do. When we get later on in the book, the state component is going to be very important that we do. But for probability purposes, we're fine. Now the plan on here, let's just do the quick sketch of it. Remember the mean on here was 24 miles per gallon, so I'm going to put that in there. The quick sketch would be between 20 and 30, so I'm going to say 20 here and between 30 here. So my plan is to find the area under the curve. To do it, all I'm going to do is my normal CDF. So as we fill that in, I'm just going to do 20 for my lower bound, 30 for my upper. I'm going to keep the mean and standard deviation at what they were. And then I'm just going to double check my calculator speak, and remember, say it's a normal distribution. I'm going to say the mean was 24 and the standard deviation was 6. When you put that in your calculator and you get the answer, we're going to get that the answer is 0.589. Now the conclusion is the last part, and all I need to say about that is something of this nature. That about 58.9% of cars get between 20 and 30 miles per gallon. So you're going to notice there's not lots of writing for the state plan do and conclude process, but it's more of a formal structure to get you ready and showing your proper work on how to actually solve a problem. So please keep this process in mind on any of those 6 free response questions that you are going to have to do on the official exam. The last thing on this video I want to talk about is section 2.2c, which is using the standard normal distribution to determine a percentile or a value corresponding to a given percentile. We're basically doing the normal CDF backwards this time. There's a way you can do it by hand with a table and with a calculator. So let me show you this. In a standard normal distribution, 20% of the observations are above what value? I'm going to sketch this on a standard normal curve. So keeping in mind our standard normal curve is right here. Now they haven't given us any specifics, so I'm going to use the z-score of 0. 20% of the observations are above what value? So you have to be thoughtful on here too. What they want to know is the top 20%. So on here, what they just told me is the actual shaded region. We know that shaded region, and what they actually want us to find now is the z-score that corresponds to it. So if you go back to your calculator and you do the second VARs or second distributions, go and find again where normal CDF was. Below normal CDF is this thing called inverse norm. When they want you to find the z-score that corresponds to an area under the curve, you can use inverse norm. And again, if you do not have the new operating system, when you hit inverse norm, if it doesn't prompt you for this, see me because you want these prompts. But all the 3 parameters are going to be asking you for is what's the area, and it's 20%. What's the mean and standard deviation? All we know it's the normal curve. We don't have specifics, so I just use 0 and 1. This is what you would type in for the calculator, and that's going to show you this appropriate z-score. Now, be careful, notice the answer. It says negative 0.84. So what it's actually just showed you is this right here. It is showing you, remember, the z-score is from that z-value below it. So it showed you this lower region. Well, we need to find the upper region. This is a perfectly symmetric curve, so what I know is this value is a reflection of this. Therefore, this z-score on the right-hand side is not going to be negative, but it's the positive 0.84. So what's the value that we're looking at? It is positive 0.84. Again, in this case, the diagram is very handy because you do, in this case, have to adjust a negative sign to a positive. If I'm doing calculator speak on here, let me just double check it. I'm going to put that's the mean, and then that's my standard deviation. And technically, this is all I would have to write, and I would be okay. In these next two examples, I'm going to show you using the calculator and table A. Here they want us to sketch the standard normal curve with our value of the z marked on the axis. So what is the z-score of where the 20th percentile sits? So if we sketch that, again, we're going to have our standard normal curve, z-score of 0. The 20th percentile, so that's on the lower end, is going to be the bottom 20% of the data. So that is the 0.20. We want to know the z-score that corresponds to it. So if I just do inverse norm on that, all we have to do is type in, again, the 20%, 0 and 1. Let's cover ourselves with calculator speak and say it's a normal distribution. I'll state the mean is 0, standard deviation is 1. When you do that calculation, what we're going to get for that z-score is it's going to be equal to negative 0.84. Again, use the gut instinct. That does seem reasonable, and that's how many standard deviations the 20th percentile is from the mean. The second question wants to know 45% of all observations are greater than what z-value? So careful with this sketch. 45% of all observations are greater than. So we're talking right here, this is the top 45%. So we want to know what percent are greater than that. I want to know this particular z-score. Now I can actually use the table to do this, or inverse norm. If I use the table, what I need to find in the table is 0.55%, and I need to look at it in reverse order. So you need to go into here and find the value that's closest to 55%, and that's going to be about right here, and that corresponds to the z-value of 0.13. So that would be the z-score that corresponds with it. It's to the right of the mean. Now if I did it on the calculator speak is very clear cut from our diagram. Be careful, the area the calculator is interpreting is 0.55, not the 0.45. So do 0.55, 0, and 1. I'm going to say that this is the mean, that's our standard deviation, and we'll just say it's a normal distribution as a quick shorthand right here. And when you do that in the calculator, you're going to get more of an exact answer. You actually get, for this case, 0.12566. If this was, for example, a multiple choice question, you would be able to decipher using either method what the appropriate answer is. So the AP board is not going to try to trick you with various roundings on this. Maybe other options they would have is, 0.15 or 0.17, so it would be easier to do either method. Now I think it's important for us to do some more examples on here. So here we have our CDC example. We have the height of 3-year-old females are approximately normally distributed with a mean of 94.5 centimeters, a standard deviation of 4. What is the third quartile of the distribution? So I like the combination of bringing in the box plot concept into a normal distribution curve. On here, if we do the normal distribution, again, you have to think about the third quartile. Remember, the third quartile is a 75th percentile. So on here, the third quartile is going to be somewhere in here. And again, what that represents in the third quartile is that this is 75% of the data. On the other end, this is obviously 0.25, if you want to look at it that way. If you want to figure out the third quartile, basically the z-score, all we need to do for that is an inverse norm, doing 75% of the data. So I'm going to do inverse norm, and I'm just going to do 75% because it's below the curve. And I'm going to use the appropriate mean and standard deviation on this one. Again, I'm going to label it. That's my mean, that's my standard deviation, and that it's normal. And if you go ahead and put this in your calculator, what you're going to kick back is it is going to come back at 97.19. So this question does want to know what is the third quartile, and in this case of the actual data. So the mean is 94.5 0.5, so that's the 50th percentile, so the third quartile would be higher. This is the appropriate answer. Now, this is, I think, is the most efficient way to do this problem, but you could, if you wanted to, do this as a z-score instead. Let me just show you real quickly. The only difference would be when you did inverse norm. If you wanted to, you could have said it was 0.75 and 0 and 1. What this is going to kick back to you is an actual z-score of this value. So be careful on any of the multiple choice questions. If they're asking you for the z-score answer was 0.674. Now, if you do it this way, if that's the z-score, you need to back into what is the quartile 3. Now, on here, to do this particular one, the adjustment would be this. If this is the z-score, I know the calculation for the z-score is my piece of data minus the mean over the standard deviation. So to solve this particular problem, I would just multiply both sides by 4. I would come and I would add 94.5 to this side. And when you do that, you're going to end up getting that quartile 3 is 97.19. So this is another way of doing it. It is worth understanding the second perspective, because sometimes the multiple choice questions, the only way you could do it would have to actually reverse from the z-score and find the actual value using that application. One more complete example. Let's refer back to the car model we were looking at, where we had the mean of 24 miles per gallon, standard deviation of 6. Describe the fuel efficiency of the worst 20% of the cars. So we already have our curve sketched for us. The 20% of the cars we know are going to be the bottom here. So what they basically want to know is what value is that. I can easily do that with an inverse norm calculation. I need to know the bottom 20%. And I know the mean is 24, standard deviation is 6. Again, let's label this for calculator speak. Say it's normal distribution. When you type this in the calculator, you're going to get back 18.95. You could answer this question in context, and you could say that the worst 20% of all cars have 18.95 miles per gallon. Again, be logical. Clearly, my picture may not be drawn to scale. It looks as though it should have been up a little higher. That's fine. But the concept of my answer does seem reasonable. All right, part B. They want to know here what gas mileage represents the third quartile. Again, third quartile, we know that means we have the top 25% of the data up here, which means on the bottom end we have the lower 75% of the data in the rest of it. So for inverse norm, we could actually find the z-score or the value that sits there. Either choice here, I am going to try to find the value instead. It's going to be much easier to do that. So to do that, I'm going to do an inverse norm again. Here I want to know 75% for the bottom half. I'm going to put in the actual mean and standard deviation. Put that into the calculator. It's going to kick back. It's at 28.05 miles per gallon. Again, reasonable check. Yes, clearly my picture is not drawn to scale. It should have been more over in here, but that's fine. It seems reasonable. The last question here, describe the miles per gallon of the most efficient 5% of the cars. So in terms of this picture here, the top 5% of the cars are going to be on this tail end, which means what's left over in this area is our 95% of the graph. So we can do an inverse norm at 95%. So that gives us a mean of 24 and 6. When you do that calculation, you're going to get at 33.87 miles per gallon as your answer. So you could answer it and say the cars with 33.87 miles per gallon and higher are the most efficient 5% of all the cars.